Well, we know heart disease is the #1 killer for both women and men, and that's why thousands across the country tonight wearing red to raise awareness about heart health.
A team of researchers at the PSU Center for Biodevices, led by Dr. Sean Connect, have been developing a novel plasma-generating electrode that will be used in combination with a catheter to treat heart disease. This new minimally invasive method will severely reduce the risk of surgical complications while maintaining the efficacy of common procedures. Our senior Capstone team has been tasked with designing and manufacturing a low-cost, extrudable, biocompatible cardiovascular catheter body that will allow for the electrode and other fluids to be transported to the heart. Our project objectives are centered around 3 main deliverables: selecting a horizontal extrusion system, designing custom extrusion nozzles, and extruding a cardiovascular catheter body.
Our team established the following customer needs. The horizontal extrusion system must be able to fit on a workbench, have variable speed controls, and allow for interchanging of nozzles. The metal additively manufactured extrusion nozzle must be heat resistant and compatible with the selected extrusion device. The catheter body must be biocompatible, extrudable, have multiple lumen configurations, and demonstrate the proper mechanical and electrical properties. All 3 components of this project must also be low cost.
We selected a refurbished Philibot EX2 paired with a fell-fill spooler and air path cooler for our horizontal extrusion system because of its ability to meet each customer need. We decided to use stainless steel 316 for the custom extrusion nozzle material specifically for its powder availability, hardness, and heat resistance. Lastly, we selected PETG for the catheter body material because it exhibits a low temperature of extrusion, high rigidity, and high dielectric strength.
Our final nozzle cross-section contains a lumen blockage and a channel through which the molybdenum electrode wire will be fed. The nozzle tip has an outer diameter of 2.85 millimeters to ensure the catheter body will fit in the blood vessels. The head of the nozzle is designed to be fastened with a 5/8 socket, while the back end thread is set at 3/4 by 16 for compatibility with the Philibot EX2. Once complete, we set our designs to exact metals to be manufactured. We then created a design of experiments to determine the optimal horizontal extrusion system settings. We began by analyzing a basic extrusion nozzle, and we applied our findings to the next set of experiments that we conducted on our custom nozzles. After testing multiple nozzle designs at varying extrusion system settings, we were able to successfully extrude catheter bodies over an electrode with a single lumen configuration.
During the testing phase, we conducted a buckling test and high-pot test to respectively evaluate the mechanical and electrical properties of the extruded catheter bodies. These tests provided better insight into the flexural modulus and dielectric strength of our prototypes.
Our efforts will serve as proof of concept and allow Dr. Connect to further test his proposed application. The length of the samples our team has produced ranges from 8 to 12 inches, but we have successfully extruded up to 48 inches, which better resembles the length of a cardiovascular catheter. Most importantly, the cross-sections of the lumens have remained intact, verifying the structural integrity of our catheter bodies.